Morning, everybody. Thank you very much for joining me, and I do hope you had a wonderful night's rest. This morning, we will be looking at integration by substitution. So on the board, we have an integral expression, and what we are simply going to do to solve this problem is to substitute. So here, we are going to say let u be equals to 1 plus x squared. So let u be equals to 1 plus s squared. Then we are going to differentiate u with respect to x squared. So we're going to have du dx, okay, as if we are undergoing differentiation, as if we are differentiating. So if we differentiate 1, we'll get 0, and it vanishes. But if we differentiate s squared, we are going to arrive at 2x. Okay, the implication is that du equals 2x dx. Okay, remember we are to substitute for dx. Okay, and substitute for 1 plus s squared, which we are already used to here. So the phase we are in right now is to make, here we have du, okay? We want to make dx the subject of formula so that we can substitute it here. All right, so we are going to write that dx is equals to du, okay? Dx is equals to du divided by 2x. So this is what we are now going to use. We are going to use this to substitute here. All right, so let's substitute for the expression here. We are now going to write that integral x here. And then here we have roots u. Okay, this is going to be roots u because 1 plus x squared is equals to u. U is equals to 1 plus x squared. So we have used 1 plus s squared here now. We have used u to substitute for here. Then what is our dx? Our dx is now equals to du divided by 2x. So we are going to put du divided by 2x here. Okay, if you like, you can put a dot here. In mathematics or in integration, dot here represents product. Okay, it represents multiplication. So this one here, the x here, will cancel this x. So we'll be left with nothing but u, okay, u, which is inside the root, then du. Okay, this is what we are going to get. You will notice that x has disappeared from here. Okay, we don't have x again here. So it is now very simple. What we are now going to do is to re-express this. We reorganize this expression. Okay, let's bring it here. We are now going to have integral u raised by half du. So this is how we are now going to integrate this expression. When we integrate this, we are going to have u half plus 1 divided by half plus 1. Okay, to integrate means then we can add our k here, where k is the arbitrary constant. Whenever we integrate, we add this k just to show an arbitrary constant. So integrating means adding 1. So half plus 1 is 3 over 2. So this gives us 3 over 2. U raised by 3 over 2 divided by 3 divided by 3 divided by 2, then plus k here. And this will finally give us 2 over 3. When you invert this one here, okay, this 2 will come here, then leave 3 below it. So we have 2 divided by 3. 2 divided by 3, then u will remain this, then plus k. Right? So remember that in the original expression, we do not have u. Okay, since we do not have u, we are going to substitute for u. Then when we substitute for u, we are going to get 2 divided by 3. Then what is u? U 3 over 2, okay? U is 1 plus s squared. Look at it here. U is 1 plus s squared. So we are going to write 1 plus x squared. Then close the brackets. Then we're going to write this, then plus k. This is the final answer to this particular question. I hope you understood this. For those of us that are just joining, thank you for coming. Thank you for watching. I hope you had a good night's rest. This morning, what we are focusing on is integration by substitution. So an integration or an integral of this nature can only be handled using substitution, the method of substitution. So we are given an integral in which we have integral x, then to the square root of 1 plus s squared, then dx. So in this case, the value inside the square root is substituted, okay? Well, if something is used to substitute here, so we decide to use u to substitute for 1 plus s squared. And in that case, we can differentiate u with respect to x, and that gives us du dx, and that gives us 2x. Because when we differentiate 1 or any constant, okay, the differential of any constant gives us 0. So that makes this one to vanish. This one did not appear here because it has disappeared. It's now 0. 0 is meaningless. Then plus x squared. So when we differentiate x squared, this 2 will come down here to give us this 2. Then we minus 1 from here. Don't forget that differentiation means minus 1 from the power. Then dividing by minus 1 from the power. Then multiplying by that power. Okay, multiplying not the one that, not the result of subtracting 1, but the power before the minus 1. Okay, while integration means addition of 1, then dividing by 1. Okay, add 1, then divide by total power. Add 1, divide by total power. While here, subtract 1, multiply by the initial power. Okay, that is the difference between integration and differentiation. So here we have du, so we can cross multiply. If we cross multiply, we have du to be equals to 2x dx. We have du equals to 2x dx. Then we are now going to have dx equals to du over 2x. All right. Now the implication here is that we want to substitute for dx. Okay, we want to substitute for dx so that we can substitute for dx and here substitute for 1 plus s squared, and that will give us our final solution. Now, if we substitute, if we make dx the subject of formula, we are going to have dx equals du over 2x. Now we can see here that we now have dx. Okay, we have what we can use to substitute for dx. So bring in this du over 2x to this place here. Okay, then put in u inside 1 plus x squared. So that is what we have done here. So we have decided to rewrite this expression as integral x. This is x, then square root of 1 plus x squared. So u equals 1 plus x squared. So we have substituted here u here. U is now used to substitute for 1 plus x squared. Then dot. Instead of writing dx here, look at dx. Okay, dx. So we have used du over 2x. Look at it here. Du over 2x will be used to substitute for dx because that is what it is here. All right. So when we do that, x, we cancel x. Then we are left with root u du, root u du. Then we can go ahead and integrate. But before then, we have to express it in this format, okay, so that we will be able to integrate the values. All right. So if we integrate by adding by adding 1 here to the power or exponent, then dividing it by the total exponent, okay, by the new exponent. That is what we got here. Okay, and finally, we'll get u to be 3 over 2. We will get this value to be u raised by 3 over 2, then divided by 3 over 2 plus k. K is the arbitrary constant. Okay, whenever we integrate any value, we usually add k to it. For any indefinite integral, we add k to it. All right. So we are finally going to get to this level where we invert this. Instead of 3 over 2 becomes 2 here. You can bring this 2 here and leave 3 underneath it. Then we have our u to be 3 over 2 plus k, the arbitrary constant. Then here we have 2 over 3, open bracket. We can now substitute for u because we are not actually looking for values for u. All right. So we know our u to be what? 1 plus x squared. So u equals 1 plus s squared. So come here, we substitute for u here, which is 1 plus s squared, to the then raised power 3 over 2, then plus k. So this is the value for u. I hope we understand this expression. Thank you very much for watching. This is a very brief class for this morning. Towards this evening, in the evening, we are going to make a more comprehensive class. Okay? We are still going to work on, we are going to look at differentiation. We'll look at product rule and other rules for differentiation. Differentiation part 2. So please, this is integration part 2. But we're not going to go too far because what we have right now, we are short of time because students have to go to school. And as a teacher, I have to go and teach because I'm also a teacher. So thank you very much for being with me. For now, I wish you a very wonderful day. Thank you.